This is our monsoon outlook for 2024. So we're really excited about this. The monsoon, why we're talking about today, whether you're general public or all the operations that we do here, the monsoon, it's just good to be aware about it, right? We have our flooding threat, we have our safety hazards that go with the season. It just makes sense for us to be talking about it right now before it starts in the coming weeks. So to kick things off, I'm Johnny Malloy. I am the meteorologist for the Flood Control District alongside with Dan Hens. And so what we're going to do is talk a little bit about the education of the monsoon, kind of the foundation. A lot of this will probably be review for many, but we do have some new faces with the district, and it's just good to get everyone oriented on the same page. What is the monsoon, right? So to kick things off, I showed this last year, but I think it's worth seeing again. This is the climatology of lightning across the U.S. And so what you'll see here across the U.S., most of the lightning activity is focused in the Midwest, the Southeast, with Arizona, a big donut around Arizona. But as we get closer to this time of year, here we go. We're starting to see that lightning activity increases tremendously. So this is just an example of the monsoon signature that we expect in the summertime. So a really cool graphic, and it's recurring. This is climatology. This is not what we're expecting per se this season, but this is what you might expect in any given year. Enhanced lightning activity. So what is a monsoon? We are one of many monsoon climates across the globe. We specifically have the North American monsoon here, but we also have one in India, Australia, Western Africa. India is probably the biggest one in the world, but we do have that here as well. And really, what is it? Like, how do we get it? The key is that moisture, right? So as we get closer to the summer months, it's just hotter outside. So the land heats up quicker than the oceans around there, and this creates a pressure gradient. So what happens is a seasonal wind shift, large scale, starts bringing in the subtropical moisture inland. And so that is what we need for the thunderstorms here. So really this is a general example, but when we talk about large scale seasonal wind shifts, this is really what's happening here. The land is heating quicker than the sea, and that's creating a flow from the sea to the land. Right there, you see our North American monsoon, and we're actually going to dive into our local area, and this is going to be a cross-section from west to east here of the Baja, the East Pacific, the Gulf of Mexico, and the Gulf of California. That's all important for us in the monsoon. We want to look at our moisture sources. So it is the Gulf of California, Gulf of Mexico, and East Pacific. And so this schematic is fantastic because what it's showing is this monsoon circulation that develops every summer. And what we're doing is bringing that moisture inland to the mountains, interacts, we get our thunderstorms. So this is just a great example of what we're looking for right now on the heels of the start of the monsoon. So again, air flows from high to low pressure and brings the moisture with it. So this is what we hope to see here in the coming weeks. So we've all taken a drink out of the fridge, and we want to see condensation. If you were to do that right now, you wouldn't get anything. The dew point is just too low, right? And so this is a really good test, meteorologists or not, to see when we actually are in the season. Dew points, usually we're looking around 50, 55, so that will easily condense on a can out of the fridge. So we're not there yet, but we're getting there. All right, so let's move up. So that was the cross-section of where our moisture sources are, but this is looking more on Arizona from a bird's eye view. So generally in the wintertime, we have that west to east flow, right? The Pacific storm passages, right? Well, that's starting to change because of that seasonal wind shift. So now we're getting winds coming up, at least that's what we want, winds from the south and southeast. So as I let this play through here, what we want to see is the four corners high. You guys have probably heard about that. And that's part of the monsoon circulation. So this is a driver of getting the moisture, the subtropical moisture, into our area. And so this is a progression. It's not going to happen overnight. And so what we're going to look at, like even right now, there's a moisture pool developing over Central America. And we'll see that in the coming weeks as that progresses northward. There's going to be more thunderstorms. They're going to produce outflows. You're going to have green ups on the landscape. That's going to add even more moisture to the atmosphere. And you actually see a steady progression that moves into Arizona. Keep in mind, Arizona, it's a North American monsoon, but really the focused activity is the Mexican region. And we're kind of on the fringes. That's why we don't get it all the time. But it's enough to be significant in our area. So again, this is an idealized monsoon setup. So let's actually take a look at what a monsoon day looks like, an ideal monsoon day. So this is a great graphic from the University of Arizona, and they produce basically daily cloud cams. And so we can actually see what a good monsoon day looks like. And it begins with the rising sun, right? So we've all seen the clouds build up on the mountains with time by late morning, afternoon. Well, this video captures that very well. So this is in Tucson area, but it still applies for us. And here we're marching through, it's 9 a.m. All right, we're getting closer. What you're not seeing is water vapor actually moving up on the mountains, the strong thermals. And we're almost there, and we're going to start seeing some development on top of the mountains here in just a little bit. I'm telling you, it's coming. So there we go. There's the magic. So all that water vapor, all that work that was happening in the morning, that heating of the land, is actually starting to tap into that moisture source. The water vapor, even in this room right now, it's a lifting mechanism to get it to condense. So as it rises, it cools. So it basically mimics taking that can out of the fridge and getting the condensation. You're chilling the air. In this respect, the thermals are actually taking that moisture available and condensing it to its dew point. So that's why when our dew point is really high, that cloud base can be lower. So we have an opportunity for deeper thunderstorm development. If the dew point is too low, it takes higher in the atmosphere to start making cloud materials. So this is where you get that variability throughout the monsoon on any given day. This is just a great example. There's a thunderstorm blowing up there. This is towards mid-afternoon. This is typically what we'd expect when the storms start moving into the valley regions. And of course, here we go. It doesn't always get to the valley floors, but in this particular day it did. So why don't we see this every single day, right? We tend to see it on the mountains, but why don't we get it in the valleys every single day? It's chaotic. So the monsoon system, that idealized graphic that I showed you, doesn't happen every day. It's moving. It's very chaotic. So one thing as meteorologists that we're looking for is, where is that steering flow happening? And so behind me, there's 4 classic patterns that we look for that can bring enhanced flooding threat and enhanced thunderstorm days in general. And the idea here is you really do need 3 ingredients to get a thunderstorm. We may have the moisture, but you do need the lift, right? And the instability to go along with that. And we typically have the lift, and that's through the mountains heating, right? That chimney effect. We've all seen it with a campfire, where it's rising, sucking in the moisture, rising, condensing in the clouds. But the instability is definitely a wild card on any given day. So this is what keeps us on our toes from a forecasting standpoint. The instability just may not be there. And that instability is basically how deep that thunderstorm can form. So like last year, we were plagued. We didn't have good instability. Sometimes we had good moisture, but we didn't have enough to actually get the thunderstorms developed. So this is really just to highlight and showcase that the monsoon circulation is on the move. Once it sets up, it doesn't stay in one spot too long. And so just to show you a quick example, this is actually from last season. So what we have here is, you can see kind of the circulation pattern there, that it's almost reminiscent of the Great Basin High. And you see Arizona under that northerly flow. The issue is we just don't have moisture to go along with this. So the high pressure itself was blocking that deep subtropical moisture. So this is an example of what we might look for in a forecast when we hit our desk in the morning. And so I won't go too much into this graphic, but I want you to focus on this part right here. So as meteorologists, we're not just looking at the surface, right? It may feel muggy when you walk out the door, but if you actually were to take a weather balloon, which they do during the monsoon season in Phoenix, Tucson, and Flagstaff, what you're looking for is actually the temperature profile and moisture aloft. So the vertical atmosphere plays a huge role on whether we will see storms later that day. So that animation, that great animation we saw of a great thunderstorm outbreak, right? It formed on the mountains and was able to make it into the valleys. That may not happen if we have no instability. And in this case, we call this a capping inversion. So we had warmer air aloft. So the thermals were trying to rise and hit a barrier, right? The buoyancy was cut off. The clouds could not keep continuing. So this is just an example of how we want moisture, lift, and instability to combine, and we don't always get that every day. With all that in mind, it's a chaotic time of year for weather forecasting, but it is significant. So we start June 15th, September 30th. Okay, so I've already had some conversations about this, of why that is. We usually don't see our first round of thunderstorms until about early July. But in 2008, the Weather Service declared the official start of the monsoon from June 15th, September 30th. The reason for that is to be proactive like we're doing right now. It's to get ahead of that first severe outbreak. That's possible. Traditionally, if you remember, back in the day, the start of the monsoon was when your 3-day average of your dew point was 55 degrees, that moisture value, right? That key moisture value. The problem with that is if you hit your 3rd day and you reached your average, you probably already had an event that was impactful. So again, that's kind of the rationale of why having a more concrete calendar boundary on the monsoon season exists. And so, so our onset around here is around the first week of July, so July 4th, our natural fireworks sometimes with the lightning. And then really it is significant because when you even look in our local area, it can be 30, 40, even 50% of our annual average, especially when you start heading towards that core region of the monsoon in the Mexico area. So talking international border, Tucson, right? So, and just to give you a perspective, a lot of the records for the monsoon, whether it be heat or moisture, is Phoenix Sky Harbor, right? We hear that a lot. The reason why Phoenix Sky Harbor is used often in discussions is because it has such a long record. It goes back to 1895. That's fantastic for getting a perspective over a longer record, right? But we have our alert network. We have just hundreds of gauges to work with. And you can see that our average for any monsoon is actually a little bit higher than Sky Harbor. And that's because we're starting to factor in some of the more, the mountain environments, the foothill environments who have more opportunities for the rainfall. But this is a climate graph on the right here. And so the lines represent temperature, and then the bar graph represents precipitation. And sure enough, this is a monsoon climate. You'll see this all over the world, whether it be India or anywhere else. What tends to happen, you have a winter spike, and then we move into a drier spring, which we know it's very dry out right now. It is our dry season. This is to be expected. And then we have that ramp up in temperature, right? It gets very hot. But right before the switch happens where it brings in the moisture, you need the heat to have that seasonal wind shift to occur. So unfortunately, we have to have the heat. We have to have the 110s, 115s, even 120s in some years. That's a good thing, actually. So again, this is what you would expect a monsoon climate graph to look like. And we're textbook. We have that signal here. Not Sky Harbor, but this is our alert network. So this is going back 43 years. We have a pretty good record to work with and look at, evaluate, and peruse. But if you notice here, it's like a roller coaster, right? Any given season, we can have spikes, and we can also lose out, like we did last year. Last year was our second driest behind the infamous 2020 season, right? But we can have substantially more precip, up to 7 inches we've had in 2014. There's reasons for that we'll talk about a little bit later. But generally we hover in that 3-inch range. So just to be aware that we actually have an alert network out there that's capturing a lot more than just Phoenix Sky Harbor. Just want to point that out. And just highlighting the last 4 years, the four seasons, just shows you how the range that we can have from half an inch all the way up to over 6 inches. Pretty impressive. So does everyone get rain? Not necessarily on the same day. No. But from our perspective, from an operations standpoint, the flooding risk is very real. Even if it may look like most of the county or the state is not getting anything, we have forecast zones that can be impacted on a really significant basis. These storms themselves, they can be, a couple miles wide, 10 miles wide, and that's it. So looking through the record, historically, during the monsoon season between July and August, about 7 out of 10 days, actually one of our sites receives measurable rain. However, 10% of that record, we have coverage that's greater than 50%. So the takeaway there is that it rains. It really does. The monsoon has a presence here, and we may perceive it as dry, even though our network is actually picking up significant rain. So as meteorologists, again, from a forecast perspective, we just need to keep an eye on that on the daily. So this is kind of a plug-in for our daily weather outlook. This is why we're looking at this every single day, because the heart of Phoenix may miss out on the precip, but one of our areas of interest can be impacted. All right. I do want to talk a little bit about heat briefly before we move into the outlook, because the reason for this is that although we might have a dry or wet monsoon, this doesn't go away. It's going to be hot. The danger is very real. If you guys have been on social media at all, there's campaigns everywhere out there. It's the city of Phoenix, the Weather Service, us. we're really preaching the idea of heat awareness because unfortunately it is the #1 mortality rate from a weather perspective on the population. So it's important to learn and discuss about heat. And so just briefly, one thing that you might encounter in the forecasts or discussions or the news is this idea of heat index. And one thing that makes the monsoon so dangerous is it's not just the thunderstorm threat, the flooding threat, dust storms, or whatnot. It's the moisture itself. So we're already going to be hot. It's the summer season. The sun is high in the sky. We got longer day lengths. We just got to deal with that heat, especially in the urban landscape. But the moisture creates another problem. So your body has an amazing natural mechanism to cool it, right? Evaporative cooling. Moisture kind of limits that, how effectively you can evaporate that water, that sweat, I should say. And the issue is day or night. So I encourage you guys to actually look at this chart, and it's impressive how much a 50, 60 dew point day on top of 105, 110 day can make it feel like even hotter, more dangerous. And the key on the top there is when you start looking at the heat illness effects. So it's this heat stroke, any of those things, that heat fatigue, any of those heat dangers that can affect you, especially if you're out in the field. And the last point I'll bring up on this is that especially in the Phoenix area, unfortunately, that moisture doesn't allow temperatures to drop overnight, right? It's almost like a blanket. Not only are you having the urban heat island, but the moisture also traps in that heat as well by itself. So I think last year, one of the lows was 97 in the heart of Phoenix. And so as we go through a season, there's just not a chance to recover from a heat relief perspective. So takeaway message there is stay hydrated. Keep in mind that is the whole season for the long haul. All right, so with that, let's move on to why you guys are here, right? The Monsoon Outlook.
That was great.
Yeah.
What's wonderful about Johnny here, Dr. Johnny, he has a great way of taking some really complex ideas and making them pretty simple and hopefully getting us all onto the same level playing field. We've been doing this Monsoon Outlook now really since I've started at the district. I know my predecessor was very big into talking about this, and then we just wanted to keep doing that and continue on that legacy. But it's been well over a decade, and we could come up here and just tell you, all right, well, we think it's going to be hot and dry, or it's going to be a wet monsoon. Or we can try and teach you something, and you can get a better understanding as to what we go about in terms of this complex system. So we're going to talk about the 5 or 6 really important things that we look at every year that may or may not give us some insight as to what might happen in the future. Johnny made a really good point earlier to say that this whole thing, the monsoon complex, the circulation, it's erratic, it's irregular, it shifts, it moves. So this isn't an easy, A plus B equals C science. There's a lot of things that go into it, and we're often wrong a lot because, again, it's very complex. So I'll talk about each one of these factors first, and then we'll show you what the data is telling us, and then we'll give you a best guess at the end, and then hopefully you guys have a few questions. Johnny and I are both going to put input in because even he and I can't decide sometimes on some of these things what it's really trying to tell you, but it's good to get the extra perspective. Let's give you the whole picture. So first thing we're going to talk about is antecedent conditions. So soil moisture, temperatures, what was it like over the winter? Well, as far as temperatures go, we were right around normal. We had some cold outbreaks, and we've had some cold and warm periods through the spring. Nothing like last year. It was very, very chilly. Also, though, in terms of rainfall, the whole western U.S. did pretty well over the winter and early spring. We had quite a few rain events. Watersheds are being refilled. Soil moisture's up. So why does this matter? So there's been quite a bit of research that's talked about your antecedent conditions. If we want to get that monsoon ridge, that ridge of high pressure, to start moving north in June, July, and August, one way we can inhibit it is actually if we have lots of western snowpack, colder temperatures. The land can't heat up as fast as we want it to, faster than the ocean, to help drive that circulation. So this data right here is kind of saying, if you were to look at it as its own little piece here, when we have a normal to cooler than normal, along with lots of moisture and antecedent winter, that might inhibit the northward progression of that monsoon ridge. Maybe a later start, maybe a regular placement of the ridge. This was a very strong signal last summer. This year is still kind of a signal to this, again, maybe a later start for the ridge moving north, but not quite like last year.
It's a little bit different. Yeah, because you hinted at the snowpack, and we're just not seeing that. If you pull up satellite image right now, the snowpack is not nearly what it was last year, especially when you're talking more towards like April or May. But again, that's kind of the stages that you go through, right? You got to melt off the snowpack, then you got the wet soils, then you got to dry out the soils, right? Then that heating from the sun towards summer can go directly into that land-sea contrast that we want. So we're kind of already went through the snowpack phase, but we still have this wetter than normal soils, perhaps, to work with. And the key here, just like we're talking about heat, where it can trap the energy. Basically, it takes energy to evaporate. That's why moisture is so significant in any part of the environmental system from an energy transfer perspective. So if we got moisture in the soils, that energy from the heating of the sun has to go into that to evaporate. So there's a delay.
There's a delay.
There's a delay. That's kind of the lag effect.
So let's look at June now. So June is our traditional let's bake month, right? Monsoon hasn't started, but we just roast, maybe even the end of May. Well, what you're looking at on the left here is geopotential height at 500 millibars. What am I saying? It's about halfway up in the atmosphere. Higher heights are represented by those yellows and oranges. You can associate them with warmer temperatures, higher pressure. The lower heights are going to be the blues, purples, colder temperatures, low pressure. What you're seeing on this left image here is the pattern in June, typically some type of troughing off the west coast of California, with the monsoon ridge across central Mexico slowly starting to nudge its way up into the desert southwest, is what we have currently going out there right now. You can see the ridge over central Mexico trying to nudge its way north. It's being enhanced by this Baja low off the coast of Mexico there. But this is kind of like what we want to see, generally west to east flow and a developing ridge across central Mexico. What does this mean for us in terms of temperatures? These are the forecasts for the next 14 days, hot. And then to finish out the month of June, very hot. Odds statistically say if you were to play out the last 3 weeks in June 10 times, 7 to 8 of them are going to be above normal in terms of temperature. So odds favor it being hotter than normal. And that's what we want to see if we want to help get that ridge and make it move north. And one other thing, people are saying, well, what are the odds maybe that we see an early onset, see any precip? Well, again, odds favor us to be right around normal, maybe get a quick false start kind of thing on there. But you have to, this time of year, normal rainfall is nothing. We don't typically receive rain in early half of June or even the late half of June. So even if we got a quick event, it would be virga, light rain, but nothing significant. So we are going to move out into the sea surface temperatures out in the ocean. Again, we've been doing this for years. We talk about some of our focal points, and the ones we're going to talk about are the Gulf of California, and then the equatorial Pacific to talk about ENSO, El Nino, La Nina. So we're going to start with that equatorial Pacific here first.
All right. So as you heard, last year we had the El Nino event, significant El Nino event, right? Well, there's already signs of that breaking down. So we are actually moving out of El Nino and moving into what's called a neutral phase. And then perhaps high probability, based on the Climate Prediction Center, of going into La Nina by the fall and winter months. That's important. And just to give you guys an idea, we're not always in an El Nino or a La Nina. There actually is this transitional phase, right? It takes time. Anything with water, there's a lag effect, basically. So what we're looking for now on the right side, well, let's focus on the left side first. So what you're seeing is the blue is the La Nina. And so the higher that bar is, the higher probability versus staying in El Nino or staying neutral is. And you can see that by the fall, winter months, the Climate Prediction Center is basically almost a slam dunk. We're going to be in a La Nina phase. And that's matching up with the trends right now. What does it mean for us? So before we get into La Nina this fall and winter, we got to get through our monsoon first, right? So on the right here, this is basically showing you the idea of how much precipitation typically happens in our climate division. It says climate division, but that's for the Phoenix area. And so when you look at the data and you kind of categorize it by El Nino, neutral, and then La Nina for the summer months, July, August, September, there are some differences that show up, right? So the key point here is if you focus on that red line, so this is going to be the mean of what you expect during an El Nino through a summer, neutral through a summer, La Nina through a summer, of kind of where you are. But importantly, you can see that there's a lot of range in the historical record when we have a neutral transition over the monsoon that overlaps with it. And so unfortunately, this actually gives us even more unknown when it comes from a monsoon outlook standpoint. Probably don't want to hear that, but that means there's going to be more variability that we have to watch for as meteorologists forecasting wise. As we go into next summer though, odds favor when we have a La Nina event active during the monsoon, we tend to get a little bit more precip. So that's something to look forward to on our next outlooks. That could be actually a huge discussion point to come. But right now we have to get through this new neutral phase, which unfortunately historically is one of the most variable times that we can have in terms of precipitation over the monsoon.
So you're telling me anything can happen basically?
Unfortunately, yes.
If it was just based on ENSO? Okay.
Yeah.
So that's not telling us a ton.
And that's typical. So with a lot of forecasts, there's a lot of attention on the ENSO, right? El Nino, La Nina events. But keep in mind that's more of a global picture. When you look at the monsoon, kind of what I was discussing a little bit earlier, there's a lot of local and regional nuances that can enhance your precip on any given day. So we do want to talk about El Nino and La Nina because there is a driver in the global weather patterns. But for the summer months, we tend to lose that signal on hanging your hat on an El Nino or La Nina. So that's the idea there.
All right, moving on. So what we're looking at now are sea surface temperatures in the Gulf of California. You're kind of seeing the Pacific region here, and then I'm kind of blocking for some of you, but the Gulf of California up above to my right. The reason it's important is there's been quite a bit of studies that were done in early 2000 that try and link as the temperature goes up in the Gulf of California when we actually see our onset to the monsoon. And the magic number here is 27.5 degrees Celsius. When the northern Gulf that I've highlighted here in red reaches that 27.5 degrees Celsius, what we've seen is that the onset usually happens within a week of that. Right now, we're currently sitting about 24.5 degrees Celsius, so the temperatures there tend to heat about a degree per week. So that's about 3 weeks, give or take, until we potentially could see the start or onset of the monsoon, which would put it right on time. So that's a good thing. So we only have 100 days to utilize storms, and if we can get the thing up and cooking by the time we get into early July, then that gives us more opportunity for rain. So this is, count this as a pro for initiating the monsoon for storms. And again, not to say right here in Phoenix, but across the desert Southwest, the state of Arizona, New Mexico, California, Texas.
Yeah, and I'll just point out too real quick. So the Gulf of California, it looks very small compared to the Eastern Pacific, Gulf of Mexico, but it's such a significant source of low-level moisture for us. Having discussions about this earlier, but we'll often look at Yuma observation on the northern part of the Gulf as kind of a window into how much moisture might be moving in. So there are these things called Gulf surges, right? And it has to deal with the way the land and the sea is and the pressure gradient. But we tend to have basically a low-level jet form. And this is a huge, huge factor in how much moisture we get into our local region in Arizona. And at times we may only get, a day or two advance warning on this. So it's a little more complicated than that, but just to let you know that we focus on the Gulf of California for a reason. It is significant for us. This is interesting. So Dan was showing you how we have right now kind of a cool anomaly in the East Pacific and even the Gulf of California, right, with the sea surface temperatures. So this actually factors into the official hurricane outlook. So you can see how there's overlapping outlooks right now. And so this is important for us because we do want to look at the hurricane outlook for the East Pacific because this could be a significant source of precipitation for a monsoon. So just the way it's spread out through the summer and early fall months, we kind of get our rain in different forms, whether it be the daily thunderstorms, but also towards the end, we see more activity from a tropical standpoint, which can be very significant. And I know people in this room can tell exactly what that means. So we'll talk about that here in a sec. But right now, because of those cooler waters, the official forecast is a little bit suppressed hurricane outlook. So that could factor into our end of the season precipitation.
Suppressed for the Pacific, enhanced for the Atlantic.
Yes,
There's been quite a bit in the news about the Atlantic being active this year, and that is the forecast for a very active Atlantic season, just to make sure we're clear on that.
Yes.
So as we were mentioning, this type 4 transitional pattern, Johnny talked about the 4 patterns. This is the one that is what helps drive that tropical moisture, those remnant systems up and into Arizona later on in the monsoon. So if we're having less tropical systems, less opportunity to get that moisture north, that's why we put boom or bust. This can turn out to make things southwesterly flow that's dry if you don't have the presence of a tropical system. So most years we're always like, that's our wild card. That can be the thing that changes what happens. Odds of that being the case this year might be a little bit lower than normal. So chalk that up to maybe drier. What we're looking at right here, this is a great point, and just to keep feeding off of this here, you're looking at accumulated rainfall in the y-axis, and we're going forward in time from the start of the monsoon to the end, and you're looking at the average rain across Maricopa County, our alert network. So you're seeing this time, these mass curves. As we move through the monsoon, you see the values go up. This dashed black line is our average rainfall when averaged across all of those 40-plus years. And then we're looking at some individual years, a couple of the wettest and a couple of the driest. So the green and red, 2020 and 2023. And then we can see in orange, blue, and purple here are some of our really wet, so monsoon 2021, 2022, and then our purple, this is the one I want to talk about, 2014. So that particular year, we had put a forecast out for it being hot and dry. And again, tropical systems being the big wild card. And sure enough, that forecast, my goodness, it looks so good. Starting in June and July, right around normal. It was very, very hot. Rainfall, we went from being around normal to below normal rainfall. And all of a sudden, the switch kicked in that August and the hurricane season kicked on. And we had remnants of Hurricane Lowell. That caused the big event in early August, October 10th, 12th, that flooded I-17. That event took us from being around normal to, oh, we're wetter than normal. A few weeks later, September 8th, the big event, the Big Daddy, the Super Bowl of our events in 2014, where pretty much every major roadway flooded, all the parts of the valley, even, of course, Lake Durango became the Ocean Durango out here as even our complex flooded. That Norbert system put us from, again, a wet to one of the wettest. And sure enough, we still had remnants of Hurricane Rachel that came in at the end of September and gave us a fourth significant event. It just goes to show that even when we have all the signals pointing towards hot and dry, all it takes is one of these systems that basically can destroy our forecast. In this case, it was great. I said it was going to be hot and dry. It ended up being really wet. Everyone forgot. And that's okay because we went wet. But again, it is chaotic. It's difficult. Even meteorologists, scientists, climatologists, all of us that study this, we all argue about what we think is going to happen because, again, it's never clear-cut. So it's just a nice way to show it here. And this, again, looking at the last 5 years, we're as dry as can be, as wet as can be. So you really sometimes just don't know. But with that, this is the official forecast in regards for temperature from July, August, September. Odds strongly favor above normal temperatures. All the climate model runs, the statistical model runs favor this outcome. Very, very hot. We had a really hot last summer. We did in 2020. It's possible we see something similar. As far as rainfall, those models, and again, some of the components we talked about, that antecedent conditions, the ridge placement trying to get north, all kind of point this picture of more erratic ridge placement and potentially lower below normal rainfall. So will that be the outcome? Yet to be seen, but if you were to let the monsoon play out 10 times right now, and we were to have 10 different outcomes, 4 of them are probably going to be drier than normal. 4 of them are going to be wetter than normal, and 2 are going to be right around normal. So if you take the 6 out of 10 theory here, that's kind of where we're at. So
mixed signals, basically, is the idea here.
Yep. So if you just want to summarize that then, Johnny.
Yeah, so again, unfortunately the heat's going to be sticking with us. There's really good signals on that front. However, the precip is a little bit of a wild card, as we've been talking about, especially with the kind of reduced outlook from the hurricane tropical perspective at the end of the season. So we definitely want to keep an eye on there. But just a quick perspective on that too. Last season could have been very different. Kind of a quick aside here. Do you guys remember Hillary? How that created record precipitation in Southern California. And even from an operational standpoint, we were watching that. And really, the shift of 100, 200 miles of a circulation can mean a world of difference. So really, we got spared, California got slammed. And if you look at some of the footage on there, it's devastating. That landscape just doesn't seem that kind of rain. So just to emphasize how much of an end-of-the-season chaos can happen from a tropical standpoint. So, and really, yeah, the idea here is our coverage of storms may not be impressive on a daily scale, but we can have one significant one. So it only takes one for flash flooding, especially in an urban interface where it's already we can have flash flooding pretty quick with just the environment that we have, the concrete, just the urban in general. And so, yeah, I think with that.
If you're looking for resources about the monsoon, our folks in our iOS department have spent quite a bit of time putting together this maricopa.gov/monsoon. I highly encourage you all to go check it out. It'll give you everything you need to know. And again, it's not just flood control doing this. This is flood control, McDOT, county health. Everyone got together to talk about what are all the things we need to know before the monsoon, when the rain starts and the flooding starts, and then after all that happens. Great source of information here. So please check it out. Also, as Johnny mentioned earlier, we do produce a daily weather outlook. You can grab that if you hop on the flood control webpage, pop on that weather outlook tile, subscribe for email updates. You'll get our weather outlook sent to your inbox. We also, and it'll look like this, gives you the day 1 through day 3 along with rainfall potential, flood potential. We also issue flood warnings. Those don't get sent out to the public, but you all work here at Flood Control. If you'd like to get a heads up as to when that heavy rainfall, severe weather is coming, you can sign up and we're happy to add you to the list. And again, especially for operations, a lot of you have projects going on around the county that may be influenced due to flooding. Here's a good way to get an early heads up so when you come into work the following Monday, you're not surprised that your project was flooded out or whatnot. So we also do lake alerts too, which again, summertime is the time everyone's up on the lakes. You may take your family up there. Sign up for these. We try and give a heads up to all the main county lakes for adverse and severe weather. So with that, thank you.
All right, thanks guys.